Talk about SOHCAHTOA. SOHCAHTOA, that doesn't really make sense, right? Well, it's what's called a mnemonic device, which means it's a way to remember something. And given the title of the video, you can probably guess it's about trigonometry. Okay, so it's all about sine, cosine, and tangent, those three trigonometric ratios, 1, 2, 3. And they just stand for what those ratios are built out of. So, for example, SO is sine, and then the opposite, and the hypotenuse, because when we build sine, it's sine of theta equals the opposite over the hypotenuse. Right, so 1, 2, 3, 1, 2, 3. Okay, and then ca stands for cosine, adjacent, and hypotenuse. Right, because when we build the cosine ratio, it's cosine of theta equals the adjacent over the hypotenuse. So again, the center bit here is the top bit here. Okay, and then the last one, TOA, you can probably guess, is tangent, opposite, and adjacent. Okay, so it's tan of theta equals the opposite over the adjacent. Now this is great because if we just remember SOHCAHTOA, it's fun to say. If we remember SOHCAHTOA, then we can remember all of these equations. Because we remember, okay, it's SO, and that's sine, and then opposite on top because the middle goes on top, and then hypotenuse on the bottom. So it's like SO, ka, toa, right? Because the middle goes up. SOHCAHTOA. So why do we care about SOHCAHTOA? Why do we need to have this SOHCAHTOA? Why do we need to memorize these? Well, we just kind of memorize them as a product of the next bit we're going to do. So far, we've done questions where I've told you that, this question is going to be sine, this one's going to be cosine. But what if I just give you a question where we just have a triangle? Just a triangle. And we don't know what we're supposed to use with this triangle. Well, we can still use our labeling to figure out what we have. We can start with that. Okay, so if we look at, this is our angle down here, just this 37, and we go all the way across, we know that across from this angle down here, we should have the opposite side. Okay, and we know that with this square corner down here, all the way across from the square corner should be the hypotenuse. And then technically the third side would be the adjacent, since that's neither of the other two. Okay, but we don't really care about the adjacent today because right now we have the opposite and we're looking for the hypotenuse. So this is where SOHCAHTOA comes in. We look at SOHCAHTOA, S-O-H-C-A-H-T-O-A, and we look for, okay, which of these ratios has both the opposite and the hypotenuse? Okay, so let's check out tangent first. So tangent, it has the opposite, but it doesn't have the hypotenuse. Okay, let's try again. Cosine has the hypotenuse, but it doesn't have the opposite. Look at sine, has the opposite, has the hypotenuse, so that's the one we're going to use. So then we'd start setting up this equation. We'd use sine of theta equals the opposite over the hypotenuse, and then we could fill in the values that we know. Sine of 37 degrees equals 12 over x. And then we could solve it from there. We've done videos on that. I'm not going to take this to the solution. The point is we figured out what ratio to use just by looking at the triangle. Okay, so let's do a couple more like that, just figuring out what ratio do we use. Okay, so again, we start just by labeling some such. So we've got a square corner over here. And if we look all the way across in the square corner, we should have a hypotenuse. And since there's two sides that touch the angle, the hypotenuse, which is over here, and then the other one is the adjacent. Okay, so then we write out our SOHCAHTOA. Once you get good at doing this, there's no need to write out SOHCAHTOA. You'll just kind of do it in your head, but I like doing it just as examples, just because it does help. So we look at this here, we're looking for adjacent and hypotenuse. Sine has the hypotenuse, but not the adjacent. Cosine has adjacent and hypotenuse. Awesome, it's got both. We can stop there. Okay, then we do cos of theta equals adjacent over hypotenuse, and then we'd sub in and continue on from there. But we now know that this one must be cosine. You notice this time I didn't solve the third side in terms of labeling it. I didn't say, like we know it's the opposite, but there's nothing over there, so there's really no reason to label it. There's no reason to confuse yourself with that. We would only need to label it if we weren't really sure which one we're supposed to use, and then we can check, what has something, right? Unless a question asks you to specifically label that side, you don't necessarily need to. Okay, last one here, because this one is an angle, right? So we'll see, is it different? Is it the same? Like, how does it work? So let's take a look. Because we still know that the angle's here, which means we still know that if we look across from the angle, we will get the opposite side. And we know that since this side across from the square corner is the hypotenuse, we know that this side must be the adjacent. Okay, so we've got numbers on the opposite and the adjacent. So we know we'll have to use the opposite and the adjacent. So we write down our SOHCAHTOA. Again, you might be jumping to the solution already, and that's great. If not, just keep following along. So we're looking at adjacent and opposite. So we look on the first one, on sine. We've got the opposite, no adjacent. Cosine has the adjacent, no opposite. And tangent has the opposite and the adjacent. So there we go. So it must be tangent, which means it's going to be tangent of theta equals our opposite over adjacent. And then you just solve that in the same way that we solve all the angles, leaving the theta as is and filling the numbers here, and so on. Okay, so really pretty much the same method when you're just trying to figure out what ratio to use. Okay, so again, it's just labeling your triangle, figuring out what sides you have in play, and then matching it on SOHCAHTOA.